Today, let's talk about something truly amazing. It's squishy, it's jelly-like, and it holds a whole lot of water. It's called hydrogel. Think of it like a super sponge, a really, really super sponge. Hydrogels are made of special long-chain molecules called polymers. These polymers are like microscopic spaghetti strands all tangled together. When you add water, these strands don't dissolve. Instead, they grab onto the water molecules and hold them tight, swelling up into a soft, wobbly gel. It's a solid, but it's mostly liquid. Isn't that wild? It's a state of matter that is just fascinating to consider, a true marvel of chemistry. So where did this wonderful watery stuff come from? Well, the first modern hydrogel was invented way back in 1960. Two chemists, Otto Wichterl and Drafoslav Lim, were working on a new material. They wanted something that was soft. They wanted something that was flexible. They wanted something that could hold water. They mixed some chemicals together and poof! They created a polymer that loved to soak up water. Their first big idea for this new material was for the human body. They thought it could be used to make something that would be comfortable to put right on your eyeball. That's right, they invented the material that would become the first soft contact lenses. It was a game changer for people who needed glasses. You might be surprised to learn that you probably use hydrogels every single day. They are hidden in all sorts of products, quietly making our lives easier and better. One of the most common places you'll find them is inside disposable diapers. That super absorbent core that keeps babies dry, that's a hydrogel. It's a special kind called a super absorbent polymer, or SAP. It can soak up hundreds of times its own weight in liquid and lock it away, turning it into a gel. But it's not just for babies. Hydrogels are also a huge help in the world of agriculture, especially in places where water is scarce. Farmers can mix hydrogel crystals into the soil around their plants. When it rains or when they water the fields, the hydrogels soak up extra water like tiny reservoirs. Then, as the soil dries, they slowly release the water back to the plant's roots. This means farmers don't have to water as often, saving a precious resource. It also helps plants survive droughts. It's a simple, brilliant way to make every single drop of water count for our food supply. Let's not forget about medicine. Hydrogels are superstars in the medical field because they are so soft and water-based. Our bodies usually don't see them as a threat. This makes them perfect for things like wound dressings. A hydrogel bandage can keep a cut or burn moist, which helps it heal faster and with less scarring. It also provides a cooling, soothing sensation, which feels great. Some of these bandages are even infused with medicine, which the hydrogel can release slowly over time, right where it's needed most. This is a much smarter way to deliver treatment. Beyond bandages, hydrogels are essential in tissue engineering. Scientists are using hydrogels as a kind of scaffolding. This leads us to one of the most incredible innovations: 3D printing with hydrogels. This is called bioprinting. Researchers are using special 3D printers that use hydrogel inks mixed with living cells. Layer by layer, they can print complex, three-dimensional living structures. They have already successfully printed small-scale versions of tissues like liver, skin, beating heart muscle. It allows scientists to create realistic models of human tissues to test new drugs, helping to make medicine development safer and more efficient. And what about self-healing materials? Yes, hydrogels can do that too. Imagine a phone screen that could fix its own scratches. Scientists have created hydrogels with special chemical bonds that can break and then reform. If you cut this hydrogel in half, you can simply press the two pieces back together. After a short time, the chemical bonds will find each other and reconnect, healing the cut completely until the material is as strong as it was before. This could lead to self-healing car paint, self-repairing soft robotics, and countless other products that fix themselves, reducing waste. Scientists are no longer just making simple, squishy gels. They are creating smart hydrogels that can respond to their environment. Think of it like a robot, but without any wires or electricity. Some hydrogels can change shape or release a substance when conditions change. Imagine a drug delivery system that only releases medicine when you have a fever. Bam! The gel activates and releases medicine exactly when needed. Other smart hydrogels can react to light or to specific chemicals. Scientists are developing hydrogels that can be injected as a liquid and then cured in place by a special light, plugging wounds or forming scaffolds without major surgery. Bioprinting with hydrogels is moving fast, printing tissues for drug tests and, eventually, replacement parts. We can already print skin and tiny heart muscle. Full organs remain a challenge, but the progress is real. One big future use is environmental cleanup. Hydrogels tuned to absorb oil or heavy metals. You could spread them over a spill, let them soak up contaminants, then collect them easily. It would be like using a chemical sponge to clean our planet and help secure clean water for communities. Hydrogels could make electronics soft, stretchy, and wearable, like a second skin. By embedding conductors, we can make flexible circuits, sensors, and maybe even stretchable batteries. Imagine health monitors as comfortable as a temporary tattoo, constantly sending data to your doctor. Hydrogels could help grow food in space, holding water and nutrients at plant roots where microgravity makes watering difficult. This makes hydroponic farming more reliable for long missions. Back on Earth, hydrogel-infused walls could evaporatively cool buildings, reducing energy use. Buildings that breathe, absorbing moisture by day and releasing it at night, could make cities more sustainable. Hydrogels could become a fundamental building block of the green architecture of the future. A future smarter, healthier, more in tune with our planet. The simple, squishy hydrogel reminds us humble materials can be powerful. With science, we can engineer a better tomorrow, one polymer chain at a time. It's about spotting a problem and creating a scientific solution. See the problems it has solved and the amazing things it might do. The future is wondrous.